experiment was first studied in 1940 by Frank Hertz and presented to the German Physical Society. Shortly after Bohr's theory of the atom was presented, it was the first electrical measurement to show the quantum nature of atom. The experiment consists of a vacuum tube designed to study the energetic electron that flew through a thin vapor of mercury atom. It was discovered that only a specific amount of an atom's kinetic energy will lose as the electron collide with the mercury atom. This confirmed the prediction of quantum theory that electrons occupy only discrete quantized energy state. This experiment support both model of atom. For this great invention, they have been awarded Nobel Prize in Physics in the year 1925 for their discovery of the laws governing the impact of an electron upon an atom.
Next, we will go through the experimental setup. The Frank Hertz tube, which is shown in the above figure, is the major component of the experiment. A vacuum is created in the tube, which is subsequently filled with an inert gas, which is typically mercury or neon, and the gas is thereafter maintained at a low pressure and steady temperature. Then the temperature of the tube will often be controlled as part of a typical experiment. And the current being monitored during the experiment is often output using an oscilloscope or a graph plotting device. And different parts of the tube are subjected to 4 different voltages. To properly comprehend the tube and how a current is created, we shall describe the portion from left to right. Just a metal filament K is heated using the first voltage UH, then thermionic emission is used to produce free electron in this, which is heat energy overcoming the electron work functions to break the electron free from its atom. Then a metal grid G1, which is kept at a voltage V1, is located close to the filaments. The newly liberated electrons are drawn to this voltage and then travel across the grid as a result. Then U2, an accelerating voltage, is used. The electrons are hurriedly moving toward the G2 second grid as a result. Then the stopping voltage U3, that this second grid is maintained, act to prevent the electron from getting to the collecting anode A. The measured current is generated by the electron gathered at this anode. Then the experiment essentially consists of changing the accelerating voltage and measuring the impact on the current after UH, U1 and U3 value have been selected. Next is the uses of Frank Hertz experiment is to verify the atomic system have discrete energy level by bombarding electron and observing the difference in energy level with an electrometer. And the next one is to confirm the quantum theory, which predicted that electrons occupy only discrete quantized energy states.
Following that, the theory of the Frank Hertz experiment can be seen that it explained in terms of elastic collision and inelastic collision between the electron and the gaseous atom like mercury. So, based on the definition for both collision in the box given, shows that the electron that travels slowly will change direction after elastic collision, but they do not change their speed. However, electrons that travel faster will lose most of their speed in elastic collision, and this lost kinetic energy is deposited into the mercury atom. The atom will subsequently emit light and return to its original state. For your information, the electric current measured in this experiment was the result from the movement of an electron from the grid to the anode. So how electron move from one plate metal to another plate metal? In order to draw the emitted electrons, grid voltage need to be made in a positive with respect to the cathode, while the electric potential at the anode need to be slightly more negative than the grid itself. The reason is because in order to let the electron have the same kinetic energy as in the grid. And to your knowledge, electrons were accelerated by a voltage towards a positively charged grid in a glass envelope filled with the mercury vapor. If the electrons have a sufficient energy on reaching the grid, some electron will pass through the grid, and as it reaches the collecting plate, it shows that the current in a circuit overcome the existence of the retarding potential between the grid and the collecting plate. Likewise, with the electron which does not have a sufficient energy on reaching the grid, this electron will be slowed down and will fall back to the grid. Again, the value of accelerating voltage where the current drop will give a measure of the energy necessary to force an electron to an excited state. Hence, the experimental result that we show after this will confirm this theory and the existence of discrete energy levels.
Next, we go to the result of the Frank Hertz experiment. So, this is the overall graph that we can see and observe in mercury. First of all, for point A, no current is observed. It is because the stopping voltage cannot be defeated by the accelerating voltage because it is too weak. As a result, no electrons arrive at the anode and no current is generated. For point B, the current rises to a first maximum. The electrons are given enough energy by the accelerating voltage to overcome the stopping voltage, but still not enough to exit the gas atoms. The electrons have higher kinetic energy as the accelerating voltage rises. As a result, the current increases due to the shorter tube crossing time. For point C, the current is at the first maximum. The electrons now have enough energy from the accelerating voltage to excite the gas atoms. Collisions that are elastic can happen. The current may begin to decrease following an elastic collisions because the electron may not have enough energy to overcome the stopping potential. For point D, the current drops from the first maximum. It is because due to the elastic collision with the gas atoms, which have their own random thermal motion, not all electrons are traveling in the same direction or even the same speed. As a result, certain electrons will require greater acceleration than others in order to attain the excitation energy. Due to this, the current is decreasing gradually rather than quickly. For point E, the current is at the first minimum. It is because there is a maximum number of collisions that can be excited gas atom. As a result, there is a minimal current and a maximum amount of electrons are not reaching the anode. Next, we go to the point F. For point F, the current rises again up to a second maximum. After losing energy in inelastic collisions, the accelerating voltage is raised to the point where electrons are accelerated enough to exceed the stopping potential. Average inelastic collision positions migrate down to the tube to the left towards the filament. The kinetic energy argument mentioned in B causes the current to increase. For point G, the current is at the second maximum. The electrons can now travel the entire length of the tube with enough energy provided by the accelerating voltage to excite two gas atoms. The electrons accelerate engage in an elastic collisions, accelerate once more, engage in additional elastic collisions, and eventually lacks the energy to overcome the stopping potential, causing current to decrease. Next, for point H, the current again drops from the second maximum. It is because the impact in D causes the current to progressively decrease. For point I, the current is at the second minimum. The number of electrons that can experience two inelastic collisions with gas atom is achieved. A second minimum current is attained as a result of a maximum number of electrons not reaching the anode. For point J, this pattern of maxima and minima then repeats for higher and higher accelerating voltage. The pattern then continues as the length of the tube is filled with an increasing number of inelastic collisions. It is evident that the Frank Hertz curve minima are evenly spaced barring experimental uncertainties. The distance between the minima is equal to the gas atom excitation energy. For example, mercury is 4.9 electrovolt. The pattern of equally spaced minima that has been found is proof that the atomic energy level must be discrete.
In conclusion, as the electron collision is elastic, the electron will not lose energy on colliding with gas molecule in tube. As the accelerating potential increases, the current also increases. As the accelerating potential reaches a particular value, each electron possesses that much of potential, which is 4.9 electron-volt, will make the collision become inelastic. As a result, the energy level of electron bound to the atom is raised. Each electron gets sufficient energy to participate in two inelastic collisions. They excite two mercury atoms and no energy will be left. This process will repeat for each interval 4.9 electron volt.